yes. The idea is to have a kind of type and effect system where you type a program with some type tau and give some bound on the I/O effect that the I/O operations that this program is doing, right? So what I'm considering is that I have a number of fixed channels, and I can read and write with them. So for effects, I have well, the empty effect or no I/O, and reading and writing, but it can be of a variable or something, so it's existentially bound. And we have sequential composition of effects. So first this effect happens and then the next one, or the program will do this effect or that effect, or we keep repeating some effect, right? And also this kind of dependent effect where you can say, well, this program reads X and writes X, right? Something like CAD program that I use as an example here. Okay. And then for types, you have some simply typed number calculus, basically. And the function types can have some suspended effect, right? And you can be polymorphic in the effect. The idea is that the program's effect is actually polymorphic in what effect its input can make. As you see, effects can be suspended, right? Okay, and the goal is to have a unary and binary logical relation to reason about these things. I will make that a bit more clear. Okay, but by safety, I mean basically safety. So if you forget about this tracer stuff, if a program reduces to some other term, if your term reduces to some other term, then it's either a value or it will reduce further. So the basic safety condition. But we also keep track of this I/O trace that the program produces during execution. And then at the end you want to say that at any point that you look at the program's execution, right, the I/O trace is actually a prefix of the traces that are allowed by, or that correspond to this effect, right? And when the program is done, then it must be in those sets. And by a trace, I mean, so you have either the empty trace, or you will write some value, or you read some value from a channel, right? And by what correspondence means is basically, well, the empty effect corresponds to the empty channel, and if you're reading some value, basically you're reading it, and it's more or less clear for the rest. And also for dependent ones, you would say for all C, for any character it should hold. One thing is that here I assume that the set of traces is closed under reordering of I/O operations on different channels, right? And the reason we will see is that I want to kind of hide buffering effect, right? I want to say that the CAD program that doesn't do buffering and the one that do buffering have the same effect, basically. Okay. Okay. And in a binary relation, I want to say that the two programs are related to some effect, such that whenever one of them, whenever the first one, under any context, evaluates the value with some trace, then also the other one evaluates the value with some trace. The traces correspond in the sense that they both have to be in the same effect kind of constraint, right? And only differ up to reordering of I/O on different channels. Right. And the idea is that you want to prove that CAD with buffering kind of refines CAD without buffering, right? And also things like this parallelization theorems that we just saw. But saying that if two programs are doing I/O on disjoint channels, then we can just do the I/O in parallel, right? Okay, so the language that I consider is a simply typed lambda calculus, right, with CBV, call by value evaluation. And I add two basic operations, one reading on a channel, and I bound the read value to some variable, and continue, right? Or writing. Okay, and so let's see an example here. We have this CAD program which reads until the end of file, reads, and whatever it reads, it writes back to another channel, right? And we want to say that this, we want to prove that this program has this effect, is it reads something and writes it back and repeats this operation. So we have the basic typing rules that you could imagine. So for a recursive function, you would say that it has this type. If assuming that the function has a type, the body has the type, right? But here we also consider the effects. And for the reading and writing, it's more or less clear. It's what you would expect. Right? But just to notice, if we say just eta is this read x, write x, right? It doesn't immediately match. So if you look at this, it either, in case it's EOF, it does nothing, or it does one read write and then repeats, right? So we can syntactically apply this strict type. And I use here a kind of effect subtyping, and say that you have this subtyping relation on effects, and if you have a subtyping relation, you have typing with one effect, you can say that you have. And the idea is that you can weaken the effect and say that it does more things or a bit of a different thing. Right? Like here, we could just say that these effect subtypings, that doing nothing or doing something repeatedly is just doing that thing repeatedly, and doing once and repeating is just the same as repeating. And then you would get what you would expect, right? That this has the type that we set. Right? Okay, and now to what we mean by this polymorphic effect, and use polymorphic things. So consider this buffering. Buffering, what I consider buffering, is basically a suspended write. And we can see that it has this kind of effect. And what I can do with these buffers is basically I can combine them. And then this will be a kind of an example of this polymorphic function that basically gets to, if you look at the body itself, it takes two buffers and commits them one after the other by suspending it, right? And the typing, this is basically the OCaml syntax for what is here. The typing is what you would expect. That given any kind of I/O effect, if you get two functions that do these two effects, and then this body will have the effect of doing the first one, then the second one, right? And we add this typing rule. Basically, it says if you have that your term E has some type, then you can abstract away this thing. So, and the E itself, I say, has no effect, but the effect can appear in the type, right? So it can be some suspended effect. And one example here is this cat with buffering, which basically reads one character from the stream and creates a buffer, reads another one. If it succeeds, it combines the buffers and commits the compound buffer. Otherwise, if we have reached after reading the first one, it just commits the buffer, or if we are already at the end of the file, there's nothing. And you can see that it basically, again, similar to what we had. It's either read X, write X, or it reads X and then reads Y and then writes X and then writes Y. Right? And so here we add this kind of reordering effect subtyping. This is a mistake, it should be one of these. It says basically you can take two operations if they are on different channels and just swap the order. Right? And then we can get from this thing that we say read X, read Y, write X, write Y, to read X and then write X and then read Y and write Y. And then because then this part is free of Y, I can take it out, and then this part is free of X, I can take it out, and this basically reduces to 2 times read, write, read, write. Okay. And then by some more effect subtypings, you can see that this cat with buffering actually has the same effect. Just read, write, read, write. Okay, and so this, what you would expect is that at the for any subtyping, the traces actually are included, the way that you would expect. And at the end, you want to prove that any well-typed term is safe with respect to that. And the idea is to set up a logical relations in a program logic like Iris, similar to what was discussed, right? And then an invariant would govern what the kind of a protocol for the channels. Right? And then you can basically prove this. And it's rather a general kind of framework, so you can basically say that any program, even pure ones, have the top effect basically. You can read whatever and write whatever, right? You can weaken the effect. And it's a kind of a system, so here I only talk about this specific dependent and polymorphic, the simple ones. The idea is that you can have a system where you can have parts that are very precise with the effect and parts that are not, and then you can have parts that you prove in the model using the logical relations that have the effect that you are saying, and then say that if you put it together with the part that is checked by the compiler, the whole thing is the effect that you want, and so on. Okay, thank you. Yes?
Yes. So this concerns me. One thing about this, about your talk is that the effect language you have is very rich. And could you go back to the slide where you do the buffer that way? So it looks like your program transformation was proved entirely by X subtyping? Like,
yes.
Okay.
So the program doesn't change. It's just effect subtyping, yes. Yeah.
So, yeah, I was wondering if you had any examples where it was easier to give a type to, like interleave the program transformations and the type changes. Like, is it easier to show that this term inhabits a particular type that you can touching? Or are you only thinking about well-typed programs?
I was only thinking about well-typed programs, but that's an interesting question. Right?
I have probably a stupid question too. So can you go back to this slide where it was the type for the combine function on the buffers?
Yes, you might mistake.
What are the effects in these positions?
So what you... Actually, there shouldn't be any. You're right. That's a mistake. Yes, yes. There shouldn't, because it's a call by value, so they should be evaluated, and it should be a function type, and effects should be suspended. That's true. Yes.
Okay, that.
Yeah. It's a mistake.
Okay, any other questions? Then let's thank Ramin again.